this video will show how you can set up the M8920A for DMR testing. In this example, we'll show also how you can create the signal using Signal Studio's custom modulation and run basic measurements on the SA mode. So to begin with, just ensure you have the right license for this application to run. You would need the general purpose digital radio test bundle or the M9093 for the spectrum analysis side, as well as M9094 for custom modulation generation. So we have this license, so we can go ahead and set up for digital testing. First off, we'll check that we are in the right mode, radio test and digital TX. So let's hit OK. Now we'll just proceed to change frequency settings as well as amplitude, megahertz. We'll go to amplitude and change the range to 35. And under input output, we will want to make sure the RF output port is TR. Now let's go ahead and add a radio generator view. So let me do that to the right of at the bottom here. So by default is no data, just pick the RF generator. So that's what I have and I'm happy. Now we'll proceed to create the Signal Studio DMR signal. So just make sure you have downloaded Signal Studio. And we will then select the M9381A/M9383A Pixie vector signal generator. Once we are here, just ensure under custom modulation, it's custom IQ. Let's click on custom IQ. We have some predefined setups and we will then go ahead with DMR. If you scroll down, you can choose a different payload, but we will go by default of PN9. Just check the deviation reference, that's 1.944 kHz for FSK. So we're happy with that. I will go ahead and export this waveform data. So just make sure you know where this has been exported to, as we will need to recall this waveform file that we have just generated. So let's save. Now I can hit back into the backend side. So under RF generator, make sure this tab or this view is highlighted. We will now hit recall. We'll go to waveform and we will point this folder to where we have downloaded the waveform file we generated earlier. So this is the file that I would like to recall. I'll just recall and close this. So we will also then change the frequencies as well as power levels so that that's something we can see. So these are just sliders for us to check that out. So that's the amplitude and that's the frequency, so it should match. Now we'll go to mod setup. So instead of analog, it will be ARP or arbitrary, as we will now point to that waveform file. So if you did not recall the files, the waveform will not appear here. I have recalled those files, so I can then go ahead and pick the file that I'm after. So let's just hit OK. So it then tell you that the waveform file is selected. If you do not have the license, you might be prompted with a license issue error. So we will turn on the ARP state, hit back to RF generator. If we click up, that should now be ticked. Now if we hit back here, we will just want to double check that the input port is also TR. That has been set. So before I turn on RF out, I might just want to go to the constellation diagram on the bottom left and go to measurement setup. So we will preset to standard. The default is none. So just to help with the constellation diagram, I will hit on radio, and that's DMR. Hit OK. So that should be closed. Now if I head to RF generator and turn this on, I should see the DMR signal centered at 851 megahertz. We can always put on a marker. That's where we are, and you can see that the constellation diagram shows the 4FSK signal we generated. The deviation is not too far off from what we have sent. You may also head back to constellation diagram, measure time. If you notice earlier, it was saying there was no burst, so you may want to turn this off if there is no burst. And now we have something a little more stable. And this is what we have for the DMR testing. You can always key in the transmitter and check for the frequency deviation for this DMR test. So that's all I have. Thanks for watching.